All right, as always, please pause the video until you've read this thoroughly and wrapped your brain around all of what you've read, hopefully, so maybe read it more than one time. And hopefully you've even attempted this already, but here we go. Essentially what they want you to figure out is what the y variable represents in this system of equations. Now remember, 41 was the total number of arrows, 206 total number of points, 7 points for every arrow that lands in the bullseye, and 4 points for every arrow that landed in the surrounding ring. And so when you look at the system of equations they gave you, and I guess you don't know what x is supposed to be either, but something plus something. So whatever x is and whatever y is, it looks like they're supposed to add up to equal 41. And 41, of course, was the total number of arrows. So, I mean, you can almost start to figure out that your y variable is probably one of the numbers of arrows, because there was 2 types of arrows. So it looks like x is going to be how many certain kinds of one arrow, and then y would be the number of the other kind. And so when you look at the other equation, and you look at that, the y variable is being multiplied with the 7. And if there was 7 points given for every arrow that landed in the bullseye, you're thinking, what would get multiplied to that 7? Like this y variable, what would it represent such that we needed to multiply it with the 7? Well, it shouldn't really take you that long to figure out that the y variable should be the number of arrows that landed in the bullseye, because of multiplying the y with the 7 in this equation and just being here in this other equation. Part B asks, how many points did Kelly score for all the arrows that landed in the surrounding ring? Well, if we're going to figure that out, we need to know how many arrows landed in the surrounding ring. And that is going to be our x variable. So we need to figure out what x equals. So we're kind of going to, what we're basically looking at here is we're going to have to solve the system. Well, at least for x, aren't we? Like, I guess we don't need to solve the entire system in part B, or maybe at all. But we definitely need to figure out x. So let's write this system down again. And we're going to need to solve this system for, at least for x. Now, remember there's a lot of different methods. The 2 most reliable methods, I would say, are the substitution method and the elimination method. I'm going to choose, at least at first here, I'm going to choose the elimination method. And remember, that method I call the addition method because we're going to be looking to add the equations together. But when I do that adding of the equations, I want one of the variables to cancel out. And so I need either the x's to be opposites of each other or the y's to be opposites of each other. And I don't have that. And I guess the other thing I should mention is that everything needs to be lined up. So the x is lined up, the y's are lined up, equal signs, number constants. So, I mean, that's actually the very first thing you need to make sure is going on when you're going to do this addition method or elimination method. And remember, we really just need to figure out what x equals, okay? So I guess if you're really thinking ahead here, we need to make the y's the opposites so that I can solve for x. If the y's go away, I can solve for x. So right now I got 1y and I got 7y. And they're not opposites as they are now. But how can I make them into opposites? Well, the opposite of 7y is negative 7y. So I guess I could multiply this equation by negative 7, and that'll get the job done. So remember, we're going to multiply negative 7 to the entire top equation. And what is negative 7 times 41? Go into my calculator. Negative 287. And then this bottom equation was good as it was. Didn't need to change it. And so now, like I want, those are gone. Negative 7x plus 4x is negative 3x. And negative 287 plus 206, once more to my calculator, is negative 81. And now, my remaining equation, I can just get x by itself. And it turns out that well, for now I'll say that x equals 27. Remember, x was the number of arrows that landed in the surrounding ring. And what was the original question? I mean, what were they asking? You know, like, is 27 the final answer, or was there something else they were sort of asking for specifically? And remember that they want to know how many points was that worth. So those 27 arrows were worth how many points? Well, they're worth 4 points each. So if we do 4 points apiece times the 27, that should get me a final answer of 108 points. Now we can move on to part C, where if you've already read this, and again, pause it if you have to before reading this and before moving on, I guess. Okay. So now we have like another archer, Deschamps, and he had 12 arrows total. So if you understand the reading, there was 12 arrows total for him and 72 points total. And they just want you to write a very similar system of equations as very similar to what Kelly had. So what they say, let x and y have the same representation as they did in Kelly's system. Well, okay. So then if we added the number of surrounding ring arrows with the number of bullseye arrows, remember Deschamps had 12 arrows total. You know, this goes to the same format as Kelly's. And therefore it would be 4x plus 7y to get Deschamps' 72 total points. Not really much to explain there. Part D, a third archer, Lou, wrote a system of linear equations to represent his performance of scoring a total of 100 points. He solved the system of linear equations and found that his solution was 6, 8. Explain how you know that Lou made a mistake and solve it. Okay, all right. So all we know about Lou is that he scored 100 total points, and if his solution was 6, 8, 6 being the solution for x, that means x equals 6, which means 6 arrows in the surrounding ring. And the 8 part, that means that he figured out that y was equal to 8, which means 8 bullseyes. 8 arrows in the bullseye. All right? So explain how you know that Lou made, how is that wrong? Why can it not be true that it was 6 arrows in the surrounding ring and 8 arrows in the bullseye. Well, let's double check. I mean, that must not equal 100 points. So let's see here. We could first double check that. Let's say, so we would do 4 times the 6, because 4 points for every one of those 6 arrows, and then 7 points for every one of these supposed 8 bullseyes. And does that equal 100? Well, 4 times 6 is 24. 7 times 8 is 56. 24 plus 56 is 80. So that does not equal 100. So all you'd have to do is very clearly explain how when you check that, when you actually calculate the number of points that 6 arrows in the outer ring and 8 arrows in the bullseye, like when you actually calculate how many points that would be, like clearly say that 6 would, if a solution was 6, 8, that 6 would be the number of arrows in the surrounding ring, and that means that 8 would be the number of arrows in the bullseye. And when you calculate the points that would get Lou at 4 points apiece and 7 points apiece, that it would not total 100.